Hi guys, and today's video is going to be about the trigonometric of complex numbers. I have here 4 examples and let's get down to business. So for our first example, we have the cosecant of the 3 minus j4. So with a trigonometric identity, a cosecant of x is equal to the sine of x, and our x here is the 3 minus j4, so that is 1 over sine of 3 minus j4. Then we will use the property of the sine, which is the sine of 3 minus j4 is equal to the sine of 3 times the cosine of j4 plus the cosine of 3 times the sine of j4, and getting the multiplying the numerator and denominator by its conjugate. Then for our numerator, that will just be the conjugate of the denominator, that is sine 3 cosine j4 minus the cosine of 3 times the sine of j4 all over the multiply both values, that is the sine squared of 3 times the cosine squared of j4 minus the cosine squared of 3 times the sine squared of j4, and the sine or the cosine jy is equal to the hyperbolic function of cosine y. So our cosine j4 is just the hyperbolic function of cosine 4. Then for our sine j4, that is just equal to j, hyperbolic function of sine 4. Then we will substitute the values. Now that we have substituted the values, we can use the calculator for solving the value. So our calculator should be in complex mode and in radian mode. So the answer for the problem number 1 is the 5.17 times 10 raised to negative 3 plus j 0.04. For the second problem, we have the secant squared of 1 plus j. Using another trigonometric property, the secant squared of x is equal to the tangent squared of x plus 1. So our x here is 1 plus j, that would be equal to the tangent squared of 1 plus j plus 1, or we can distribute the power to the outside. Then we will get the value for the tangent 1 plus j. Later on we will raise that to square. So that is just tangent of 1 plus tangent of j all over 1 minus tangent of 1 times the tangent of j. So that is equal to the tangent of 1, and tangent of jy is equal to the j tangent of hyperbolic function 1. So our y here is just 1 all over 1 minus tangent of 1 times the hyperbolic function of tangent 1 times j. I forgot to put the j in the hyperbolic function of the tangent, So I will just put j on the front. Then we can now solve using a calculator, and that would give us the answer of 0.27 plus j 1.08. Then we will go back to our original equation. So our tangent 1 plus j is equal to 0.27 plus j 1.08. So we will get the squared of that and add 1. So the value for the secant squared 1 plus j is equal to negative 0.1 or 10 plus the j 0.59. That should be 0.59. So let's go to the arctan of 0.2 plus j 0.1. First, we let the arctan of 0.2 plus j 0.1 equals to a, and we will get the tangent of both sides, and the tangent of the arctan is equal to x. So that would be the tangent of a is equal to 0.2 plus j 0.1. Then the tangent of a is equal to the sine a over the cosine of a. That should be a cosine of a. So the sine of a is equal to the e raised to ja minus e raised to negative ja all over j2. Then the cosine of a is equal to e raised to ja plus e raised to negative ja over 2. Then the 2 will cancel each other, so that would result to e raised to ja minus e raised to negative ja over the j times the e raised to ja plus e raised to negative ja equal to 0.2 plus j 0.1. Then we will cross multiply that will be equal to e raised to ja minus e raised to negative ja all over e raised to ja plus e raised to negative ja equal to j of 0.2 plus j 0.1. And then we will multiply both sides by e raised to ja plus e raised to negative ja. So multiplying the j, that would result to j 0.2 minus 0.1. Then it will cancel on the denominator, and the remaining would be the numerator, equal to j 0.2 minus 0.1, then multiplied by e raised to ja minus e, or plus e raised to ja rather. And then we will distribute the j 0.2 minus 0.1 to e raised to ja and to e raised to negative ja. The next step, we will multiply both sides of the equation by e raised to ja. Then that would be e raised to ja squared, then minus e raised to 0, which is equal to 1. Then another e raised to ja squared, and plus e raised to 0 equal to 1 times the 0.1 plus j 0.2, which is equal to negative 0.1 plus j 0.2. Then we will transpose the values so that similar variables will be on the same side of the equation. Then we will factor out the e raised to ja squared, and that would be e raised to ja squared times 1 minus negative 0.1 plus j 0.2, and that is equal to 1 plus negative 0.1 plus j 0.2. Then we will divide both sides by 1 minus negative 0.1 plus j 0.2, and then we will take the square root of both sides, and that would be e raised to ja and equal to the square root. And then we will get the ln of both sides, that would be 1, then the remaining would be ja equal to the ln of the square root. Then we will transpose the j, so our a is equal to negative j ln of the square root. But we can simplify the values inside the square root. That would be 0.9 plus j 0.2 all over 1.1 minus j 0.2. Then our final answer is the arctan of 0.2 plus j 0.1 is equal to the negative j ln of the square root of 0.9 plus j 0.2 all over 1.1 minus j 0.2. For our last problem, we have the arc cosecant of negative 0.3 minus j 0.4. First, we will let A is equal to arc cosecant of negative 0.3 minus j 0.4. Then we will get the cosecant of both sides, and the cosecant of arc cosecant x is equal to x. So that is cosecant of A equals to negative 0.3 minus j 0.4. And the identity for cosecant of x is equal to 1 over sine x, and sine A is equal to e raised to ja minus e raised to negative ja over j2. To simplify the fraction, that is just j2 over e raised to ja minus e raised to negative ja equal to negative 0.3 minus j 0.4. Then we will cross multiply, that is j2 equals to e raised to ja times negative 0.3 minus j 0.4 minus e raised to negative ja times negative 0.3 minus j 0.4. After that, we will multiply both sides of the equation by e raised to ja. So that is j2 times e raised to ja equal to the e raised to j squared times negative 0.3 minus j 0.4 and minus, that is e raised to 0 equal to 1. So the remaining would be 0.3 minus j 0.4. And then we will transpose, that is e raised to j squared times negative 0.3 minus j 0.4. Then we have minus j2 times e raised to ja equals to just the negative 0.3 minus j 0.4. After rearranging the equation, we will arrive with a quadratic equation, and we will use the quadratic formula to find the e raised to ja. So that is negative b plus minus the square root of b squared minus 4ac all over the 2 times the coefficient of a. Then we will simplify it further. The square root of negative j2 is just negative 4 minus multiply the terms, that is 0.28 minus j 0.96 over 2 times negative 0.3 minus j j 0.4. Then we will get the ln of both sides, that is ja equal to the ln of j2 plus minus the square root of negative 4 minus 0.28 minus j 0.96 over 2 times negative 0.3 minus j 0.4. Then we will transpose that j to the other side, that is a equal to negative j ln of j2 plus minus the square root all over, or we can simplify it over negative 0.6 minus j 0.08. And now the value for the arc cosecant of negative 0.3 minus j 0.4 is now equal to negative j ln of j2 plus minus the square root of negative 4.28 plus j 0.96 over negative 0.6 minus j 0.8. That is our final answer. In this module, I learned the different trigonometric functions of the complex number and the inverse trigonometric functions of complex number. Also, the value of the arc sine, the arc cosine, and the arc tan using the long method. And also, the Euler's identity and the trig functions of imaginary numbers.